Okay, everybody? All right. Oh, okay. Video play, you can play. That's not what I want. Okay. So, let me, I mean, these are better, these slides are better arranged. That's what she was doing. So I certainly encourage you to download what she gave, what she sent to everyone. So, what we are saying is, we start, this is a hierarchical clustering. We start with the distance matrix. From that distance matrix, you can, look at, because it's a distance matrix, it's only symmetric, remember that, distance between A and B is same as distance between B and A. So you don't need this information. It's a symmetric matrix. So the lowest is here is 1.12 in this 5 observation situation, right? There I got 8 observation. We'll come back to the 8 observation again. It's a little bit more complicated. So because some of the values are same in multiple cells, that's what the complication created. So this is 0.12 is the what it says is that first observation A and B, or in this case 1 and 2. Okay, it's same as A, B, C, D, E, F is same as 1, 2, 3, 4, 5, 6. Okay, everybody, good. You understand what I'm talking right now? I'm referring to this distance matrix. Oh, this distance matrix to this dendrogram. This is called dendrogram, and in data in a point space, this is what it is. In the cluster space, this is what the structure is. In the point space, and this is A and B is this is, let's say this is A and B, right? So smallest, so it becomes 1. The closest, they get connected first. Next closest is D and C. This is D and C. You can say I should probably make it as D and C here. This is D and C. Okay, and E and F. Let's consider that. I should put that 1, 2, 3, 4, 5, 6, or A, B, C, D, E, F. So the next one is C and D. So this is gets connected. But it will not get connected. These two will not get connected because the distance between this is much smaller than the distance between the closest distance between these two. The closest distance. Are you with me? The closest distance between these two to these two is between this, and that is still bigger than this. That's why you have to wait for that distance. So when you come up to in the vertical axis, when I come up to this distance level, then they get connected. Are you with me? Are you with me in saying when this pair gets connected with this pair? It gets connected when you are talking about the distance level of this. Distance level of this. That is this one. 0.16. When you have 0.16, that is when you are covering, this is distance, remember this. Vertical axis is distance. Horizontal axis is observation. That is what the kinds of diagram of how they are connected is called dendrogram. So I'm coming back to this picture again here. These two collection of points, in this case, this is one collection of points, this is another collection of points. These two collection of points getting connected when you come to the distance level, then the vertical axis 0.16. At that time, this is getting connected to this one, and because of that, in single linkage, these two are getting connected. Is everybody with me? Please tell me, because this is what yesterday I talked about it. Are you with me, Sharanya? Okay.
Yes, sir. Yes, sir.
Yes, sir. Yeah.
Now, as you go up the distance level, that means now you are agglomerating more and more, combining more and more, bringing together more and more. Okay, combining and bringing together, agglomerating, or having the same meaning, grouping. Okay, so now, this and this. Where is my arrow? Okay, are you able to see my arrow here? Okay, so when will this get connected? So these two are connected already by the time when we reach 0.16, right? These 4 points, this collection of 2, this collection of 2 are getting connected. That means that's what this circle means. This circle means when we reach 0.16 distance, that is the minimum of the distance of these 2 points with respect to these 2 points. That is what single linkage is, minimum of minimum. Okay. So when does the next point come into play? So you take the distance between each of these points to this, or this point to this, each of these points, and this point to each of these points. And then you find the minimum of these two minimums. Okay, if that point is, by the time when it reaches point 2, at that point, this point gets connected to this collection of points. Is that clear to you? Correct? Shakti. Only those who show the face I can talk. Rajan, Rakesh.
Sir, can you just repeat one more time?
So I said, so it's about grouping observation. Clustering is about grouping observation, but hierarchically we are adding observation. That's what hierarchical clustering is. That means hierarchically means hierarchy is built on the basis of the distance, how far the points are. As the distance are more and more included into the grouping, that's what this left x-axis means. As this distance are attained, as these distances are attained, more and more observations are getting grouped together. Correct? That part is clear. So I'm saying when it is 0.2, 0.12, at that time, if it is 0.10, none of them is connected. Because the distance is, minimum distance is now 0.12 in the matrix we see. Okay? So when it reaches 1.12, the points 1 and 2 are getting connected. That is grouped together as a group, as a cluster. If I use only 0.12 as the distance, no other points are getting connected. Only 1 and 2 are getting connected. Is that correct? Very simple. So
yes, sir.
Yeah, so you say yes. I may ask simple question also. You should say yes. And then I'm saying, as I keep increasing the distance. That's what this is. When I say increasing the distance on the x and the y-axis, increasing the distance on the y-axis, then when it is 0.13, no other point is getting connected yet, because as I keep going, looking for all the other points, the next collection of points are these somewhat cream color points, right? These cream color points are the closest to these 2 points, because this is the closest. And I could have, I should have put 1, 2, 3, 4, 5, 6 now. So, Supriya, you understand what I'm saying? There's a small correction I can do here. So, when I keep on slowly increasing the distance here, right? And then 0.13, nothing is coming. 0.13, if I say 0.13, it will only come up to this. It will not get connected. This is the closest to this, right? This is the closest. But the moment I attain 0.14, it touches this. So this point gets connected. So because the minimum of each of the points with respect to this point with respect to this, there is a minimum. This point with respect to this, there is a minimum. So minimum of the minimum is reached 0.14. Oh, okay. Now these two are getting connected to the blue points. Got it? That is what single linkage is about. Shaktivel, clear now?
Yeah.
Okay. So now I keep increasing the possible distance, between.
Sir, 0.14, 3 and 4 is connected, right?
When we say 0.14, 3 and 4 is 3 and 5. Yeah, you're right. When we reach 0.14, only 3 and 4 are connected. You're right. I misspoke there. These two are connected. But then 0.14 is not enough for me to get connected with this and this. So this distance between this and this is 0.14. Maybe that was confusing. Sorry about that. Is that right? Between this and distance is 0.14. But when will this get connected with this? In the whole picture, this is the only possibility. First possibility is this will get connected with this collection. Correct? It will not get connected to this one. It comes later. This will not get connected to this one. It comes later. Okay. So first this got connected because that's the lowest, smallest distance. Next, these two are getting connected. That's the next smallest distance. That's 0.14. But when it goes to 0.16, that means it reaches the minimum of each of the points with respect to this of the minimums. Minimum of the minimums of each of the points with respect to this. Is everybody good? That sentence is very, very important. You take a distance of this with respect to these 2 points and distance of, and find out the minimum, right? That is this. And then you take out this with respect to each of these points, that is this one. Now, it is good enough. The fact that this is the minimum of these. So this distance from this is minimum between this and these two together. This distance between this and this is minimum between this and this, each of these one. A minimum of these two minimums is this. So by that time, by that distance, the 3 and 4 are, this collection of groups are connected to this one. That is what we are saying. Sharanya, is that clear to you? Okay, thank you.
Yes, sir.
Rakesh, Soumya, very good. So
Yes, sir. Yes,
the
sir.
reason why I spend time is here now. The moment you understand this, the complete and the average hierarchical clustering method will be easier for you. Because instead of minimum of minimum, I'm going to say the minimum of the minimum of the maximums. Okay. So in this case, 3 and 4 are getting connected at 0.16. We'll come to the complete momentarily. Just concentrate on this one. By the time we reach the distance of 0.16, these two collections, these two, 1 and 2, are getting connected to 3 and 4. Now we keep going. Distance keep increasing the distance. 0.17, nothing happens, right? 0.18, nothing happens because this distance is more than 0.18. And then very close to 0.2, right, which is here, 0.2, exactly 0.2. So when it reaches 0.2, then the sixth point, so this point getting connected to this one. Again, we use the same idea, minimum of minimum. Okay, we take this one, we find the minimum of these two, the minimum of distances between yellow and the blues, and we take yellow again, find the minimum of the cream colored points. And again, the minimum of that minimum is what is called single linkage, and that is 0.2. So by the time it reaches 0.2, when it reaches 0.2, the sixth becomes the group. It belongs to this group of points. That's where this connection means. That's what this connection means. Okay. Again, we continue to increase our distance, but then it takes all the way to 0.28. Okay. When it is 0.28. The 6 is also, getting connected. Is everybody good? Okay, excellent. Because once you understand
this is very clear. So this is Raja. This is very clear. I think where I was actually getting stuck yesterday was, right, I think there was a set representation, right? You were talking about yesterday. Yeah. So that set representation, we started with a combination, right, as a point. And then we are trying to relate to 3, 4, 5, 6 or something.
Yeah,
right? Or in this case, 1, 2, 4, 6, 7, 8, right? So there I was getting a bit
same
lost.
thing. How I would say is take the 0.3, the set what is the indexed 0.3, whatever it is, index 0.3. Find the distance between 3 and each one of this, and also find the distance between 5 and each one of this. That's what this means.
Right.
And the minimum of those two minimums is 1.41, and it is attained by 6. That's what we are saying. A great transition. For the 8-point problem, it is the same thing, but in order to formalize that sentence, I put it like this: we take the collection of points which are already connected, and then each of these points, what is the distance for the remaining points, and 3 with respect to remaining points and 5 with respect to remaining points, and the minimum of those two minimums is what is the 1.41 is, and it is attained by 6 points. This 0.6, indexed by 6. I think it's now clear, I suppose. Is everybody good?
I have one question. Yeah, in today's example, can you go to that slide?
Yeah. Are you able to see?
Yeah, in this, before connecting this 4 and 5, the distance between 5 and 6 is less than that, right? So why can't we group that first and then we connect to the remaining?
Well, the idea is that now, if it is a little bit not clear to you, this distance is visually supposed to be closer to this one, before this one. I think you are saying.
Yeah, but distance between 5 and, yeah, first, yeah.
Will it get connected to
group
this
5 and
before
6.
it is getting connected? Will it get connected to this before it is getting connected to this, right? It may not be clear.
Yeah, before it is clear.
It is supposed to be, if the representation is not clear, that's where the numbers will be more useful. This distance is closer to this one.
0.67.
This distance is closer to this one, 4, which is E, right? 5 and E and F, right? This distance is closer
F
to
and
this
E,
one.
4.67.
Point. This. So this distance is 0.28. That's what I'm saying.
Okay, fine.
It's closer to this one.
Fine.
before it reaches this.
Okay, I'm clear.
Excellent. Good.
Yeah, my bad. Okay.
So that's the same thing, Raja. Here, I have to formalize this a little bit more abstractly compared to, because more points are going to come. That's why I put, okay, let's take this double parenthesis and I'll say, I already found these are coming together. Now I want to find out which one is coming together closest in terms of this concept called single linkage, which means minimum. Complete means, let's just go into the complete. So in the case of complete, one second, I move very fast. In the case of average, you are taking the average of the the average distances instead of minimum of the average distances rather than minimum of minimum. In the case of complete, we are talking about the maximum, okay, instead of average. So minimum most distance is certain. This is what we already talked about, right? So let's go to the next sheet. It moves very fast for me, the mouse. So start with pairwise distance again. 3, 5, and 4 are 2 sets, each with a distance 1.4. You'll define a function called completely enclosing cover. Don't worry about the terminology, which is basically the what linkage you are using. So when we say completely enclosing means maximum distance is used, so it will enclose. Maximum distance is used, so it will enclose, which defines the distance by the next data point is completely enclosed with the previous collections. That is compared with 1 second please. So so it turns out, we are talking about complete linkage, right? So it turns out that all these pairs have 1.41, okay? And because it's only pairwise, we don't have more complex calculation yet. Next, we want to know which one comes attached to these 3. So that function is called complete, right? That's what we are talking about. So now we are talking, we have 3, 5, and then 5, 6, and 4, 8. All these pairs are there for us, right? Among this, so that means this one, right? 4, 8, 3, 5, and 2, not 2, 3 and 5, 4 and 8, and 5 and 6. Oh, this 5 and 6 is also connected, right? The 5 and 6 is also connected with the same distance. Now, the definition of complete means the remaining points are 1 to 7. The complete means here 3.1. Okay. So among these points, 3, 5, you take each one of these. It's a little bit more complex. So let me go to another example and then come back here. Yeah, there is one smaller example I have. That's the reason why I wanted to pull up this example. Okay, so this is something we we talked about, right? We talked about this one. This is not what we want. This one. So it turns out there are 3 points so we are saying, okay, so these are all the things. I'm coming back again, repeating this sentence. So I take this pair 3 and 5, 5 and 6, and 4 and 8. Each of them have the same distance of 1.41. Now among them, when we have among these pairs, we take each one of these points, find out what is the pairwise distance, let's go to 3, 5. What is 3, 5? 3 and 5. In this case, 3 and 5 is, I can use 5 and 3 also. That is 5 here. Okay. 5 and 3 is 1.41. This one, 5 and 3 is same as 3 and 5. Okay. 1.41. 5 and 6 is 1.41. 4 and 8. So instead of 4 and 8, I'll go, because I have a lower triangular matrix, 8 and 4, I go 1.41. Okay. This point, and this point. That's what in this matrix we are talking about. Now, three and 5 is okay. So among these things, these pairs, what is the next distance that we have? The next distance I have is, because I included 3, 5, 6, 4, 8. What is the next distance I have? 3, 5, 4, 8. 3, 5, 6, 4, 8. 3, 5, 6, 4, 8. The next distance I have is 2 points. 2.0. Everybody, you see this one? Among this pair, okay, if I go to this 2, when we reach 2, so when we reach 2, here you can graphically see the 6 is coming together with in this case it is 3 and 5. So with this 2 is reached, 3 in this okay. 2 is reached among 3, 5, 6, 4, 8. Among 3, 5, 6, 4, 8. The next minimum is reached by 2.0. That's what is represented here, that the next minimum, when it is reached, 3 and 5 is getting connected to 6. That's what this connection is, okay? Here. Here. Now the remaining points are 1 to 7. Okay, this is what is remaining here. Okay. Now the completion function, the complete function is, you take the 1 to 7, and what do you find here among them? The minimum 1 to 7, 1 with respect to 2 with respect to 1 or 1 with 5. 2 and 7 is you go here, that is 3.16. 1 with respect to 2, 1 with respect to 7, and 2 with respect to 7. The minimum is attained at 3.16. Okay, that is what this point is. So that is what this is. When we have 3.16, okay, we are bringing in here 3.16. 3.16 is here. Okay, 2 and 7. We are bringing this 2 and 7 together. 2 and 7. That's what this distance is about. By the time we reach 3.16, we are bringing in 2 and 7. There is a little bit more to go to 1, to include 1 here. Okay. So when do we get to 1? That is attached with 8. It says, yeah, it is attached. So it is to the minimum of 1 with respect to all these points is attained next at 8.8. That's 2.23. Is everybody good so far this size? So it's 2.23, but 2 and 1 is 2.23, but then the next value is 3.6. So when we reach 3.6, both are covered. When we reach here, when we reach 2, these both are covered. Okay. When we reach 3.6, these two are covered with 1. When we reach 6 or almost 7, right? Almost when we go to the 7, all these points are, this is covered with respect to each of these points. This is covered with respect to each of these points. Okay. What do I mean by that? When we reach 8 point something, that's the maximum here, right? 8.48. 8.48. When we reach 8.48, all of them are getting connected. Okay. These collection of points are getting connected at something around 7.28, because 7.28 because it is connected to the 3 here. 7.28. So it goes above here, 7.21, which is 7 and 4. 7 and 4. Okay. So this compared to the previous one, let's articulate that point here. Okay. Compared to the previous one, I am able to connect these 2 points with 6 when we reach almost close to 2, and these are already connected. These are getting connected only at 3 point something, and little above 3, nearly 3.6. These two are getting connected to 1, and this collection are getting connected at to this group when we find around 7.2, right? 7.28. That's what this one is, and all these groups are getting connected to this group at 8.48. So in terms of the difference between the previous one and this one, we are talking about a distance that covers all the other points. Okay, distance that covers all the other points. That's why we call it as a complete linkage, not instead of saying minimum linkage, single linkage. Okay. On the other hand, just stay put there. It's another way of drawing the picture here. Stay put there, and I wanted to say the average. I thought I saw that average here. So in the case of average, we are talking about this is complete minimum. Average here. So in terms of average, you are talking about the average distances. Okay. And it uses, all of them use the same basic distance function, distance calculations, distance matrix. But instead of using minimum of the minimum, you use the minimum of the maximums and minimum of the average. Whatever I have explained here, you can say it as the minimum, it's exactly as the minimum of the maximum, okay, whatever we have in terms of coverage. So there are 3 different methods. In this way, we can calculate the clustering. Usually, you can prefer any one of them, either complete or average or single, but each has its own definition of this, how the distances are brought together to group the observations. So commonly you can simply use the single, always you can use the single, okay. But because single somebody defined it, now other people started defining, oh, we can do this way also. That's the only thing. There is not much, much to it than using single is fine, good enough for you. So the moment you understand the minimum constitutes a way of grouping together hierarchically. We talked about additional ways of grouping together hierarchically. That's average and the complete. You are able to create the clusters of observations. One important point I want to bring here is an example of the example data that we use it for cars. This cars data set is very popular. Okay, so there are something like let's say 20 different cars, maybe 30 different cars, 28, maybe 3. Let's just count it: 3, 6, 9, 10, 13, 6, 19, 20, 23, 26, 29, 32 cars are there. Okay, and then for each of them we observe this disposition number of cylinders, horsepower, weight, carburetor type, D ratio, drag ratio, gear, and so on, miles per gallon, the number of seconds it takes to reach certain speed. So here we talked about hierarchical clustering with respect to the observations, right? Can I say that whatever we did as a hierarchical clustering with respect to the observation level? But I want to bring in the variables that describe the observations also. Rajan, your question. Remember that? This type of question you asked it twice in the past. So we grouped the observations, did the clustering with respect to observation level. This is what 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 32 is. Or A, B, C, D, E, F, G, H, I, J, Z plus another 4 characters, another 6 characters, right? But can we do the clustering with respect to the variables also? They are different. Do you understand? Everybody understands that one? That differentiation? Now, it is possible that we want to do the clustering based on both observation level and the variable level, and that's what this is called the clustering, both based on the observation level as well as at the variable level, row level as well as at the column level. And that's what this is: row level, this is the column level. Columns are attributes, variables. Rows are observations. And we can do that kind of clustering also. So the software does it for you, don't worry about it. But the principles are the same, right? So we have a hierarchical clustering here. Based on this, variables, we are saying first, these two come together, disposition, number of cylinders, and then gear and AM variable. Those two variables come together. That is actually after these to come together, it comes later. Okay, in fact, this comes together next. It comes together with horsepower, display cylinder horsepower, disposition to the cylinder horsepower come together first, right? These three variables, I'm talking about these three. Okay, and then comes this. These two comes together, gear and AM, and then comes. I think this is little or same. Let's call it a little above. Actually, a little above this one. And this is above this one. Okay, so then these two come together. Hierarchically, they are all coming together as groups. In the same way, for column wise or the row wise also, you can see the same dendrogram here, and putting them together into visually is what is called the heat map. So we have a reference here. Please go over that. Maybe in the lab session, it will be, we will do that for you. But this is the way of doing clustering both on the observation level as well as the variable level. Are you with me, Rajan? Because it's your question. There are other methods also. I don't want to talk about that. There's a Ward's method in addition to minimum, maximum, group average. There are 4 different methods of creating the hierarchical clusters. And you can see graphically the same type of observation. How
maybe different question, right? Will also refreshing some of the concepts on sets actually help to understand this better actually. So I'm just trying to.
This sets is here. Visually, it is also here. The same thing, right? I guess let's go through this one visually one more time. Huh? So this one, the 1, 2, 3, 4, 5, 6 observation. Let's say the same 6 observation here graphically, right? Here, what we are saying, the minimum of minimum constitutes 3 and 6 come together, 5 and 2 come together, and then that is the they come together. Then comes 4. But if you look at the maximum, visually it is difficult. You have to see the numbers, right? But let's see. Different ways we are trying to approach the same concept. So you can see that, this is getting connected. 3 and 6 is first getting connected. Next is getting connected with 4. But here, 3 and 6 is getting connected. It is getting connected with this group in the minimum of minimum. In the case of the maximum condition, we are talking about 3 and 6 are getting connected as before, because that's the starting point. Starting point will be same because only two observations are there. Minimum and maximum doesn't matter there. But when you come to the next point, because it's it is in single form, we are talking about the distance between 3 and 4, versus 6 and 4. This distance, minimum of the pair 3, 6 with respect to 4, okay, is 3, 4 and 6, 4. That minimum is, first of all, this is okay. 3 and 6 is getting connected, it's clear. But the next one is 5 and 2 is getting connected, pairwise. Okay, pairwise, 5 and 2 is getting connected. Next, because this is slightly smaller than this one. Okay. Now, what is the next step? Is the one that you are talking about 3 and 6 together with 4, 2 and 5 with respect to 4, or 2 and 5 with respect to 1, and 3 and 6 with respect to 1. That's the problem, right? So what we are saying is that this is coming next in terms of the maximum of these 2 points. With respect to this is the minimum of this. Minimum of this maximum is smaller than, minimum of this maximum is smaller than any other pair you can combine with this one or with this one. These 2 pair, 3 and 6 with respect to 4, that distance.
Can you put the data also next to this in the slide, sir? If we can actually try to relate better, or
we can do one thing. Okay, I think you were okay. Let me go back to this table. This is probably, that's where I'm bringing in this distance matrix here, because it could be a multidimensional data point, and that multidimensional data point is calculated as a distance matrix, and we are using the distance matrix to figure this out, right? And this one is easier, much easier than the 8 point, so because number of observations are less. So think about it, where the differentiation has to occur. We are always using the distance concept and some kind of a minimization. We are talking always minimization, but then there are different ways. In intermediate step can be different ways. The minimum of minimum, minimum of maximum, or minimum of average. So minimum is clear, minimum maximum. So you take the next point. So we found this as 1, right? And then before we come to this point, the distance between these 2, they have a distance smaller than any of these distances here. So they come together. That is clear, right? Pairwise, it doesn't matter, minimum or maximum, it doesn't matter. When we consider pairwise, it's simplest problem. It's the same thing as this. But the problem comes only when you are bringing in after the first pairwise completions are done. After the first pairwise completions are done, the problem is how are these points are going to be grouped together? What is the next point that will come together with what existing already accomplished groups? So we take the distance between, one more time, distance between 3 and 4 and 6 and 4. What is the minimum of the maximum here? That is the 6 and 4. Okay. And here 5 and 2, 2 and 4, and 5 and 4. So the minimum of the maximum here is attained by this group, not this group. That's all I'm saying. Before it comes to this point, we will come to that later. But the next one is the 3. grouping, right? 3 grouping that is attained by this group. This is well defined. This is easy to understand compared to the previous example. Because the number of examples was less. Is that clear, Raja, now?
Yeah, I'm actually the first 2 points I'm clear, actually the minimum.
Yeah.
But after that I am actually stuck actually, right? The getting to 3 and 6 to 4, if I can see the distance matrix data, maybe that will help.
Yes.
I don't know if others
Let it
understood.
go. I don't know whether this is taken from a different book. The picture is taken from a different book, but it is still talking about that interestingly 6 points, right? So let me go back and see whether it is the same data.
If somebody else understood, maybe they can also at least say what they understood. That might also help actually.
Yeah. So I'm asking other people now. Give some thoughts here. Talk to me. Right? Everybody, rest of you. Sharanya. So the question is, in the latest example I showed you, that's a 6-point example. Latest example. Look at this one. This is the single linkage. I'm saying this is the complete linkage. This is the group linkage. And this is what...
Yeah, minimum is fine. Minimum is fine, yeah.
Now, what I'm saying here, their minimum of minimum we took. The only thing is that we are talking about the distance.
So what I understood in the maximum thing, the ones which are already grouped, it is paired with the ones which are not grouped. So this 3 and 6 is paired, and 5 and 2 is paired.
Yes.
So
now we want to know
3 and 6, which is nearer, 1 or 4.
Yeah, good.
So 4 is nearer, so it is paired with 3 and 6.
Yes. 4 is nearer.
So
in comparison to 4 is nearer to 3 and 6 compared to the 5 and 2 together. Okay.
Yeah, we don't take the already paired ones. So only the left after 3 and 6 and 5 and 2 is paired, only 1 and 4 is left.
Yes.
So we check one. We check 1 individually and 4 individually, which is closer to which pair.
Right. Does that how about Sharanya? Rajan, Shaktivel, Rajan now. Gaushal. So think about it one more time. Why is that it didn't form these groups? See here, 3 and 6 combined together first as see when you are pairwise, it's the same thing. Minimum doesn't matter, maximum. That's why group, even when it comes pairwise, these are together first, right? The next point is the one that is problematic, right? Based on what type of measurement we use. Minimum says, before it goes to 4, this is, this is closer to this one, right? This is closer to this one compared to this getting connected to this one, right? So that's why the circle becomes like this. In other words, these and these are getting connected before it is getting connected here. On the other hand, here, 3 and 6 are first getting connected to 4, and before it is getting connected to 5 and 2, 5 and 2 is getting connected to 1. That is not the case here, okay? And then eventually it gets connected to all the points are getting connected. And it's because you use minimum of the maximum. Here it's the minimum of the minimum. Here is the minimum of the group average. So when we are talking about group average, it's 3 point. The group here is 3 and 6, which is the average is we are talking about 4.5, right? And here the average is 7 3.5. This is 4.5. But, I shouldn't really say 4.5. I don't remember. We have to be very careful because this is a multi-dimensional distance, multi-dimensional point-related distance. So, nonetheless, the point is the average distance, average of the distance, right? Average distance here is shorter to this one compared to the average distance, to this one. Here, the maximum of this to this is shorter than the maximum of this to this. Yeah, it should be clear now, Raja, right? Sharanya, Shaktivel, the maximum of the distance 3 and 4 and 6 and 4 is shorter than the maximum of this two distances. Okay, and instead of maximum, we use the group. Okay, so just think about one more time, we'll be fine. Now, I want to talk to you another case of doing clustering analysis, what is called the DB scan. Very, very important. It's very control F 1 second. One second. So I want to introduce another category of clustering method, third category of clustering method, very powerful, very late, it's latest method because it uses a totally different concept. Okay, the concept here is that how densely the points are coming together. How densely the points are coming together. That's what the method here is. So so let me go to this example. So k-means we saw, right? K-means is using the means. Instead of means, we can also use median. That's what k-method is. Okay. And there's also another method called Clarence. I didn't teach you, but I'm going to DB scan. So you can see in terms of the efficiency. Okay, k-means is very efficient. In terms of noise detection, it's much better. DB scan is way better than any one of these. And in terms of the identification of micro classification, it's way better than these types of methods. Okay, so what is it? DB scan first of all refers to density based on we saw KB already. We saw all these things. So let's not go back. I mean, I repeated here, so I don't want to spend time here. So let's go to this reference here. Don't worry, it looks like very complicated. It's not. If you look at that, concentrate on 3 colored points only. The points in the data points are distributed like this: blue, yellow, red. Okay. And what we are interested in is identifying the group only using those points which are dense together. Think about it. Identifying the points as group based on whether they are dense or not. Write it down if you want. Okay. Density is what matters here. Is that clear? The keyword density is what matters. Density means how close they are. Again, it's a kind of distance issue, but we are focused on the word dense. That means they're all together. Okay, dense based spatial. It's also called spatial clustering because it looks like it's more applicable in various applications of spatial clustering. Okay. So I asked you to concentrate only on 3 types of points here: blue, red, and yellow. What we are going to claim is that red are dense points, yellow are boundary points, and blue is a noise point. That's how we are going to classify this. Yellow are boundary points, blue are noise points. The only dense points here is all these red ones. So if you want to group them, then you'll say only these things only matter. These 3 things don't matter. So how do we get that solution? So we are going to define, for this we need to define, this density is density of points is characterized by defining a circle, right? Defining a circle of the same size, defining a circle, and how many points should be considered to be called as dense. You define a circle of any size, whatever the size you want, and then once the size is known, then in this case it is a epsilon radius circle, right? Epsilon radius. It's all the circles are the same type. Remember that. For a given collection of points, you define a circle of a certain radius. Once you define the certain radius, you also put one more condition: how many points it should have, minimum. So those are the 2 conditions that defines a cluster, dense clusters. So in this example, in this example, I'm saying radius is, let's say this is 1 unit, okay, or epsilon distance. Abstractly speaking, epsilon could be 1 unit or 1.5 unit. Let's call it as 1 unit. So 1 unit radius circle should contain 4 points. And whenever there are 4 points, they are all coming together as dense points. Is that clear to you, everybody? What I said? Is that clear to you, Charanya?
Yes.
Yes, sir.
Excellent.
Yes, sir.
So
But
now,
four is a fixed number, is it? As per the
yes. Given a collection of points, you define dense collection of points are defined by 2 parameters. One is the circle size, and the other one is how many points that circle should have as we move around. So basically, we scan the data points with this circle. So this circle doesn't have 4 points, so it is it's a boundary point. If it doesn't have 4 points, that's what our condition here is, 4 points. Then we say that is a boundary point. But it should have at least 1 point. But it may not have 4 points, but it should have at least 1. If it has no points at all, that's what this one is. There is no point other than that point itself. Such points are called noise points. Is that clear to you? The definition of noise versus boundary points. Boundary points will contain at least 1, but it will not contain 4 points. It will not contain 4 points. Is that clear? If it contains 4 points, a point around, within its circle contains 4 points. So let's take this one. If it contains minimum 4 points, then it is called a dense point. That's why it is red in color. Is that correct? Everybody? Let's move to this one. Okay. So this one contains 4 points minimum. Good.
So in this example, sorry, the bottommost red point, right? How is that looked at? Because that has only 3 points apart from itself.
No, totally for 4 points, right? Including that point. Including that point is 4 points here also, right? It's 4 points. This is 5 points. This is 4 points, right?
That is 4. Here it is 4. It is 4 including itself, right? In the bottom one.
Yes, including.
In the bottom one, it is including itself is 4.
Yes.
Okay. So because why I was asking it as including itself or excluding itself is if you look at A and C, right? C is actually marked as yellow. So probably that's not noise, but it's something else. So that we are saying.
It's a boundary point.
Oh, that's why we are saying it as a okay. Now
noise means it doesn't have any other point from the dense points. Any other point which is considered dense point. Okay, this doesn't have it. This has 1 point. That's okay. It doesn't have any point.
Noise, I got it. Noise is clear.
Yeah. So this one also is a boundary. Same reason it's a boundary, but this is not a boundary because it has 4 points, including that yellow point. It has 4 points. Minimum 4 points. If it is there, it's called a dense point. Is the definition clear to you, everybody? Rakesh, Rajan, I'm sorry, Rajan, Shaktivel.
Why is B
Yes, sir. Yes.
as boundary, sir?
Okay.
The distance is very small, no, sir.
Boundary definition is it doesn't have minimum 4 points. That's as simple as that. But
So
it
are
is
we
not
taking
zero.
the distances?
It doesn't have. It's not alone. Also, it's not alone. Also, it's alone means that is noise.
Are we taking the
Okay, sir.
distances between each of these points also?
Say that again.
Are we considering the distances between each of these points also, because they seem to be dissimilar?
Automatically you are considered, but the distances between those 2 points don't matter. We set a minimum. We set a condition that now, given a circle of certain size, or a sphere in a multidimensional space, it's called a sphere. And I also have another 2 conditions. What is the size of the sphere, circle or sphere, and how many minimum points it should have. Those are the only 2 conditions that defines what is meant by a dense point, what is meant by a boundary point, what is meant by noise. And accordingly, these yellow are boundary points, but N is a noise point. So within that, it has to be less than epsilon distance. Whatever is set aside at the starting circle radius size, any point, the distance between that, anything less than is doesn't matter. So we are talking about that circle size only. Am I making sense, Rajan? Rajan.
Yeah.
Distance is involved there through the circle size, the epsilon distance, right? The radius. Distance is involved. But we are saying, anything less than also is considered, is a distance too, right? This has less distance compared to this and this, but still they are part of the circle. So between the points is not the focus. The points is the circle size is what is the focus. Sharanya is good. Okay, Rakesh. Okay, Raja. We will go through some more details. Okay, just stay put. One more revision, we will be fine.
Yeah, this is clear. I think here the example is about minimum points of 4, but that's more to a discretion, right? It can be anything that we can give. Epsilon distance can be anything that we can give.
Oh yeah. It is the
Based on the
analysis
definition.
purpose. You have to try different. For your purpose, you have to try different circle size and the minimum condition. Yes, you're right.
Okay, yeah.
Remember, these are all, we have no knowledge, but we are trying to figure out some knowledge out of the data. That's all, right? No supervised information here. Okay, we are just trying to find out groupings. There are, prominently speaking, 3 different groupings: K-means, hierarchical clustering, and dbScan. That's what the point is. Okay, so here you can see, database 1 is like this, database 2 is like this. It will find all these strange clusters, strange groupings. Okay, and here is another database 3, right? And it is very fast. It can achieve, any kind of groupings like this. It will achieve for you. See the 2 and these are noise points. Do you see this one in blue color? I don't know whether you are able to see blue color. It's a noise points because inherently some kind of under some kind of a circle size and minimum points, this becomes noise. That's how I can say. These are all noise points, right? These are all noise points. And it can identify all these structures. That's why I say, a picture can be also, images can also be identified using dbScan method very easily. But people don't use that. I don't know why. People don't use it as often as they will use other methods. This is of course, this is this is one of the latest methods. Latest is usually, it may be just 10, 15 years old. Still, it's latest. Okay, it takes 30 years for some knowledge to be practiced as a standard. SVM took 30 years from Russia to USA and to the world. Russia practiced this 30 years back. Support vector machines. So okay, now the question is, how do we find out how many clusters are there? That's the problem. I thought you were going there, but anyway, it's coming here. So we have something called a method called optics, ordering points to identify the clustering structure. That's what optics is, ordering points to identify clustering structure. So the various epsilon, I'm not sure whether you are able to see this one. This means epsilon, right? You were coming very close to this question. It depends on epsilon, depends on how many observations are, right? So even if you fix the minimum number of points is fixed, epsilon can be varied, right? So you change the epsilon and draw this graph, okay? Which is the reachability distance, right? So given a collection of minimum points, draw how many observations can be, what observation can be reached. So this is the type of curve that can be drawn using the optics procedure. It's available in all, okay? Using the optics procedure, you can draw this curve. This is called the reachability plot, right? Reachability plot. In other words, the x-axis is the observations that are being used for clustering. X-axis is the observation. Epsilon is the circle size. Think about it again. Horizontal axis is observation. The vertical axis is the circle size. So as the circle size increases, you are going to cover all the points, isn't it? So if you go epsilon is here, so everything becomes as one cluster. Everybody agrees? Rakesh? If the epsilon is higher, less clusters will be there. Epsilon is here, only one cluster. Epsilon goes down, there is here 2 clusters. Goes down further, that means reduce the epsilon size. Circle size, you get more, because you are looking for more higher and higher dense collections. Agreed? When the epsilon is less size, higher and higher dense collections. So as the epsilon goes down here, in terms of distance here, you see more clusters are there. So you can find out how many clusters are there using optics plot. Agreed? Everybody? Any questions? There are variations for this. So we started with density-based spatial clustering of applications with noise, but generalized density-based spatial clustering, all kinds of stuff. Circle can we use some other shape? That's what this one is. Okay. We are talking about polygons here in circles. I like this one, the DB scan. I'm just explaining to you how to free up your thinking. And it's not that only circles are needed. And then we talk about optics ordering points. Ordering points means on the x-axis, ordering points to identify the clustering structure. So you can see that the bigger cluster is here and there are smaller clusters. Those things can be figured out, that there are smaller clusters inside a bigger cluster. That's what this optics is also helping you. Okay. So for example, when we have this bigger cluster, right, there is a small, when this epsilon is smaller, you'll be able to identify this more dense clusters, I said, right? When epsilon is smaller, that these clusters will be identified. How many clusters of smaller size like this are also there can be figured out by lowering the distance, epsilon size. Raja, you asked, you went there. I think epsilon issues. You went there. What happens when epsilon is changed? Can we change it, and so on? Yes, when you change the epsilons, you will identify more denser clusters, and these are more denser. These 3 are more denser compared to this one, but they are part of this. Okay. So those things can be identified by by optics procedure, and that tells you the number of clusters here. So when I come here up to this distance, we are talking about 1 cluster, 2 cluster, 3 cluster, 4 cluster, 5 cluster, and these 3 clusters are the fewer number of observations are there. Okay, fewer number of observations are there, and this has the large number of observations here. This is also another large group. This one is, this one seems to be this one seems to be this, and these 3 are these smaller collection of observations, which are more denser, because you don't get that, unless you reduce the epsilon. If you keep this one moving up, for example, it is not moving. Okay, so if we go up here at that epsilon, you are getting the whole full cluster here, and this one, this level, you will also activate this cluster. Okay, is that clear to you? There is also outlier factors and so on. Just the notes here, don't worry about it. You need to know DB scan and optics. Go ahead.
Sir, I have a doubt. So here in this K-means clustering and the hierarchical clustering, which one is the best, sir? And DB scan.
Okay, so there is a comparison.
We do.
I have some notes here. 1 second. That's the end of the story, end of the presentation here actually. So again, this is summarized here. DB scan, what is DB scan? A point is the core point. If it has more than a specific number of points, minimum number of points within epsilon distance, circle, and they define that dense region. Okay, and what is meant by border point and what is meant by noise point. There is a comparison here. There are additionally, I kept on drawing different pictures and wanted to show you. So I'll come to that momentarily. Ghosh, hang in there. Okay, there is a comparison here. We will compare with K-mean. We will compare with other methods. I think it is there for hierarchical also. This is not a hierarchical clustering, right? You remember that. The way I define hierarchical clustering is different than here. There is some hierarchy I build in terms of the epsilon distance, right? In terms of hierarchy I'm building to find out how many clusters are there using the epsilon distance. I also find out the number of clusters using the vertical distance, right, which is the Euclidean distance. So we can find the number of clusters using this epsilon distance or the Euclidean distance. But if you are looking for this kind of observations, like this kind of patterns, it's very difficult to find out, using other methods. These are going purely, this cluster is different from this cluster. You see this one? It's actually, they are together. But visual clustering, that's why it's called spatial clustering, right? Spatial method. This is very hard to get, some other method. It's going purely through the density of points. How you can reach see, you cannot reach from here, you cannot reach the blue at all, anywhere from here, because of the circle is only covering this much, some circle of some epsilon size, it will never get mixed up with this one. So visual comparisons, visual clusterings are all very good to achieve in DBSCAN. Answer came to you just now, Goshali. You understand what I'm saying? Some visually, separating clusters are easier to accomplish in DBSCAN because density of points is what matters. Please write it down. Density of points is what matters here. Density is still it's somewhat a loose word because there also when we say cluster, we are talking about density. But the density is tightly defined using the epsilon circles. Are you with me now? Goshali? So that's why I'm saying very strange kinds of these kinds of visually very strange, right? This one I'll show you. And I want this one. These are visually very strange looking, right? Isn't it? This one visually very strange looking. And look at this one. These two became noise, but it will not become noise in regular clustering that we talk about. And it is a noise because, from the point of view of the epsilon circle and the minimum number of points, it's a noise. And it gives rise to this kind of identification of this kind of clusters. Very strange looking, but it's a visual for, I want to call it as, because of spatial collection of points which are dense, it creates visually very interesting patterns which are very difficult to find out in analytics. Okay.
Sir, one question. So one question. So here the blue ones, right? On that you are saying it's noise actually, right? So the way I understood it was that the noise actually are not within the epsilon distance
and alone.
They are outside and they are alone, right?
And alone,
so in a typical visualization, the way I was thinking, right, is these are actually edge points that are outside. So how is it that it's actually well within the points, right? The data points is where I was.
No, for circle. Okay, let me try to.
So basically, the 1 millimeter distance or something that you're drawing and it's all out, and so it's still possible to have it within. Is the answer? Is it?
Yeah. It depends, right? I mean, it depends on the epsilon size and the minimum number of points. Something happened. It depends on the epsilon size and minimum number. Definitely.
Okay, fine. I think so. Basically, answer is it can be within also. It depends on the epsilon size and the minimum number of points. Okay.
Yeah, absolutely. It can be the whole collection of points could be in a circle, but then within that. So that's where this one I want to show. Something happened to my PowerPoint. One moment, please. Okay, it's back. So the point is now. So let's go back to here. I had a lot of different this one. Okay, look at this one. This is well defined. Okay, so all these points are boundary points. If epsilon is getting smaller with minimum points same, there are many more clusters. If epsilon is getting smaller, also if minimum points are decreasing with the epsilon, minimum points are also decreasing with epsilon, then the cluster size increases. Okay, this one, I think this is the best example that I can show you. I'm going back to the original one. This is the best example to show that strange forms of visual, spatial clustering can form with, can be created, will be part of the clusters in the DBSCAN method, because even though it is in the middle, you are right, even though it is in the middle, because it depends on the size of the epsilon, and that epsilon size should be consistent with what we are saying here, right? In other words, you can reach from one point to all the other points also. That's what it means. So that's why it's called so reachability, right? From one point to, as you move to the another point, it is containing the minimum number of points that circle is supposed to have. But if you come here and if you start here, it doesn't have any minimum number of points. It doesn't satisfy the minimum number of points condition, and then in fact it is only 1 point. If it comes with this and this together, then it becomes a well, in this case it cannot, it is obviously the minimum number of points conditions will not be satisfied here. Okay, so, and not only that, each of them should be separately a circle. So the size of the circle will be only that much for this to accomplish as the move, as a reachability condition, that is from one to another you move, it contains the minimum number of points. I think the way it is there, minimum number of points is 2. I can see that way. Okay, visually I'm figuring out visually. Does that make sense to you, Raja? The minimum number of points is 2 for a certain epsilon size.
Yeah, yeah,
So,
okay.
in that case, these two will become, noise or outliers.
Okay. No, if the minimum number of points is 2, then maybe this will also come into the whole thing, right? Maybe it's 3 or 4.
No, if it is 3, I think if it is no, not 3. I'm talking about the epsilon. I have to increase the epsilon size. See, minimum number of points is not the
Epsilon size, yeah. If the epsilon size increases, then it will be part of the group. Yeah. Okay.
Potentially, yes, definitely, yes. Okay. It's very fascinating. When I did that one, there is a reference here. I will also give you that one. The reachability is beautifully explained there with some kind of a GIF function. Okay, I will send it to you later on. So my point is that this is applicable, highly applicable in these application cases. Use a web profile if you want. They have used this in the case of user web profile in terms of clustering, color histograms. Okay, potential protein docking sites in biology, as well as land use detection. In these cases, because they are all spatially, distributed, more so than structured data. Structured data is not spatially distributed; it's a data space, right? Data space is different from spatially distributed points. Am I making sense? This one is spatially distributed points, like the potential protein docking sites, because they are very dense. This is the whole collection of protein, the amino acids collection for that protein, and within the amino acid collection of protein, there may be places where the proteins gets docked. Okay, and usually wherever the proteins are getting docked, those places will be more closer, denser, so that the docking happens, in the way it is intended, right? So DBSCAN can identify those things. And land usage is also same thing, exactly. Look at this graph here, right? So land usage, it has been successfully used to find out, the clusters of types of land usage. Okay, and also in GIS where we use usually polygons. So you remember the DBSCAN can be developed and used using polygons also, not necessarily just the circles. Okay, so using polygons, if you use polygons in DBSCAN, then it becomes more applicable to maps, GIS. And in the case of user profile, user profile distance is defined like this. If you define the distance like this, it's also known to be used in user profiles. and color histograms, because color densities can be color densities. Color means certain types of colors can mean certain levels of densities. Okay, so we can use color histograms also for identifying. Okay, now with this we are completing the clustering, and there are some references I have in this one. Maybe in the next class I'll take one of these as an example and run the R program for you. Okay, there is a DBScan and as well as HD DBScan available for you, and optics available for you to run these kinds of clustering algorithms. It's fascinating for me. Actually, I was thrilled to see interesting cases like this, very spatial cases, so very spatially defining observation, because of density is what is defining the relationship as a cluster. This is very fascinating. And as you pointed out, Raja, in between the structures, also there could be points which are irrelevant, and it will identify them as irrelevant. And accordingly, identify only this as a cluster. And this cluster, within that, there is also this pattern sitting there, and it's a different cluster. It's very, very interesting, isn't it? But in the Euclidean distance norm, this will not be easy to identify. Look at this one also. This is inside this U. So with that, we've complete the instructional part of it. Let's do the example case for DBScan as well as hierarchical clustering. We did the hierarchical clustering already. I showed you the example with 6 points and then 8 points. We can do that for, I also showed you a case of cars example, where not only we are doing the hierarchical clustering on the row side, which are the observations, which is what usually, which is what is basically the 6 observations, 8 observations are. It's about observation, but also on the variable side also we can do. So 2 ways we can do clustering, and that's what yields you the what is called the heat map. And that kind of approach is very popular in health. Okay, for gene mapping, it's commonly used for gene mapping. Okay, any questions? No questions? Okay. With that, we complete today's instructions. Sharanya, any questions? Rakesh, Rajan?
No, sir.
Gaushali, Shaktivel, Rajan.
No, sir. No, sir.
Okay. It's just a matter of practice. It's a matter of practice. Do more examples, it will be good. All right, thank you very much, everybody. I want to close today's lecture with this. We have, I think this complete, we have labs, right, Supriya?
Yes, sir.
But we completed the PA2 with this. Okay, we completed PA2 with this. So we'll do some lab work. I can show one example, maybe, with the DBScan. I'll run DBScan HD DBScan on optics. I'll show an example with that. We are good. And we'll start ML next week, Sunday.
No, sir.
I
need time for lab.
You have lab?
No, lab.
Oh.
Yeah.
Okay.
Recommendation engine is there. I have to finish factor analysis, then I have to work with clusters.
Okay.
Everything has to be done.
Okay, so if you don't do anything during the week, yes.
I don't have people coming in.
Okay. So that will extend.
Or else during the week. That's not a problem for me. One of the persons is finding it difficult. Then that's why I'm holding back. Or else I can do it. Not an issue.
Okay, that's fine. So it will extend our time. But remember that I also reduce the number of. I used to give 3 hours plus. Every time we meet. Nowadays I'm giving you 2 hours, right? So at best 2 hours.
I'll try to finish, but it will be too much of a rush.
No, I think it's important that they also grasp,
That's it.
receive it.
Yeah.
It's important.
Mm.
So, Rajan is it's going overflowing. Is that correct, Rajan? Something like that, right? Just hang in
There's
there.
too much.
No,
There's so much swing in the pitch.
Yeah, I mean,
So much of dendrograms going on.
I think I don't know whether I'm not blaming or anything, but we want to give you enough value. We want to see this from the value point. See, when you go, you are the master. I mean, this is the graduate level training, actually. I would like to hear one-on-one. We will talk about it now, one-on-one, how else it can be done, because we also want to shorten the time period, right? And we want to give you all these things, I don't think anybody teaches easily DP scan. DP scan I haven't seen, okay? So we give all these important things, and we reduce the time, and that we call it as a boot camp. It's hard on you because you are also working, you have other things to do, but you'll get there. Your commitment is eventually what matters, because you will grab them and hold them. You will grab them and hold them. If not today, tomorrow you will visit that, and you will see, oh, it's interesting. That time we didn't have time enough, to focus. So it's a kind of pressure on both sides, right? You believe in us that we give you all these things. We want to give you all these things, and we reduce the time to learn these things. That's a pressure on all angles. That's that pressure is coming together. I hope you enjoy it. Because if you cannot go, it is extremely hard to try to spend your time yourself and organize these thoughts in a way that you bring it. It is almost impossible. So it takes years. So we are very proud of doing that, but it demands a lot from you also. And I'm very thankful that you have been holding on. You're all very strong people. It may go above your head and so on sometime, right? But you're there. You're sitting there. You're also trying to hold on to it. So I appreciate that. Eventually it will come to you. Remember, these are all, humanly evolved issues. Even average person, they have to spend time to learn this. So just take it easy, commit, come back again and again and again, question yourself, why do I need this? Why do I need this? What is the simple code I can use? Because you are going to talk to your practitioners. When you become managers, you will talk to your practitioners. Or when you are an analyst like Rakesh, I'm also an analyst. Okay? So when people are like us, then we write our codes. We spend our time and so on. We come back to this from a different angle. When you're a manager, you need to have this terminology, these interconnections. Otherwise, you may not be able to guide them. Eventually, people like to be guided. We don't do that enough of it, in real life. But even if you're a CEO, others want your guidance. It's not like I'm a CEO, you go and figure it out. The directional points, the strategy, the CEO, if he gives that, then the company is great. So CEO is also a manager. So you will be able to guide your team. You'll be able to take your team to the next level. So with that, I want to stop here. I always advise you a lot, I guess. Maybe you like it, you don't like it, I don't know. But I wish you all, you all enjoy the friendship and the learning process. Thank you for the opportunity. Shaktivel, I'll catch up with you. I am fascinated by your stuff. I'm a little bit fascinated, definitely, with your stuff also, Rajan. We write NIH projects too. No, I don't write personally that much. My wife does it. She's an healthcare expert. I'm fascinated. I want to know what you're doing. If you can, talk to us. Talk to me. That's fine. That would be great. And
I'm doing a lot of things. Can I just say? So I'm doing a lot of things. I'll reveal by one every week.
And repeat that again.
I'm doing a lot of things. I reveal one by one every session.
You're talking about the learning here or your personal interest, innovations?
My personal innovations like that.
Yeah, I mean, there's so much opportunity, it's fascinating world. I think your parents said, go and do whatever you want. Or your wife said, whatever. There's so much to do. There's a fun time. If you keep up your health, it's joyful. Keep up your health, don't get distracted, enjoy, do whatever innovations you are doing. Creativity is same as innovation. Creativity is fun. And I guess you have a team. You're alone or you have a team?
Currently I'm doing alone.
Alone.
But I'm planning for team.
You're looking for a team?
Your team is there.
Right? Rajan says he right.
Yeah, your team is all there. You have Rakesh, Raja, Soumya, Gaushali, Saranya.
Yes.
And even Supriya is also there.
Yeah.
No, what else do you want?
So for me, my requirement is very simple, Shakti. Those who want to drop, you can drop. But we're talking about general things, okay? My interest is very simple, Shakti. Help me design, test, and release what is called data science platform.
Yeah, I'll try my best.
Yeah, I'm not sure whether it is within your pathway, but I am interested in that. I've been thinking about it for quite some time. As Charanya pointed out, I posted this in LinkedIn also. I asked somebody, hey, what's the best platform? So I'm trying to do that, and I want to make it in mass if it's possible. That's where the opportunity is.
Okay, sir.
So there will be the gaming computer became only recently popular. There was what is it called? The gaming computer with the head, Dell bought that for $1 billion, something like that.
You're saying Alienware?
Oh, Alienware. Yes, Alienware. I never heard of that for some time, but suddenly Alienware became popular. These are very big, flashy buttons, this and that. Very heavy also. I don't know why they're so heavy. But anyway, people got fascinated. The gaming computer became popular. I think Dell bought it for $1 billion plus or something like that. Or maybe HP, I don't remember. Rajan, anything about it? Yeah. And they were only doing gaming computer, nothing else. So there is the specialization needs are always there. Of course, gaming industry is very big. I think data science industry is also very big. Data industry is also there. When we say data science, remember machine learning, AI, everything is there. And if you can also container it with the software packages which are up to date, it's a huge advantage.
Yeah, in medical field, data science is very important role. Plays an important role. I see a lot of things in my internship. There are many data they are using, like for small things, like what you say, for testing a sensor, like an ECG. So some smaller sensor, they are using the data scientists.
So, for example, I'll tell you why this is a problematic. You saw that the recommender engine was not working. For me, it was trouble because they changed the codes, and the codes are not up to date within R. And those are the things we have to make sure when we say container, to create a container software system, container database system, data science systems. When we create a data science systems, powerful data science system, it will have all this package reliably there. Anybody can say, okay, I have this one, it's reliable. If they have trouble, they call the organization. And we give the support saying that, oh, in your case, this is the problem, you fix it, this, it will be fine. Or you do the setup here, configuration like this, you will be fine. Because of something happened, it becomes what is called, it's an organic, self-contained system, right? I am interested. I'm very, very much interested because this is a constant trouble for data scientists. On top of it, now you think about, even the recommender system, it's only a test system. How do we make sure that that system can be used for creating an app in real time and field it also over, let's say over cloud, right? There are multiple steps involved there. It's not easy. Right now, it's not easy. It takes time. That's what I'm trying to say. There is a software engineer who has to come into the play along with the data scientist. They have to work together. Then only they can make sure that the recommender system is fielded through a cloud platform. Am I making sense? But if we can make this data science system that can do such kind of works as a container, self-contained system, then it has a lot of value. I have given you the whole idea of my interest. For that matter, Rajan, you are invited, Raja, and others. But it requires a lot more careful thinking because it's an entrepreneurial activity. Commitment is there, investment is there, plan is there. All those things come into play. But I know, younger generation who are fascinated, who are, who don't have other distractions, they're fascinated just for doing the fun work. They will carry this kind of stuff, very fast. I know that much. So think about it. And it's a call to everybody. I'm not discriminating any one of you. I know everyone can do a great job. It's not, whether it is Sharanya or Raja or Rajan or Soumya, certificate project. Every one of you can do it. I know. Can participate also. But it has a different mental attitude. That's where the things can be a little bit off, right? Because, for example, if you are interested in doing PhD, it doesn't fit into your pathway. Forget it, right? I'm just saying. But if you're looking for opportunity in this new modern world, you can be anywhere. You don't have to be. I don't have to be in Nepal or India or China to do a job, or you don't have to be in USA or Switzerland to do the job. Doesn't matter. Okay. I want a more closer look at your system. I'm still not fully getting your, what's the uniqueness there. I know you have put a very sophisticated machine, but I want to take a very close look at it. When you have time, call me. Send me a note. Send me an email. Okay, Sakti.
Yes, sir.
I'd like to hear more about your project if you are, if you don't mind sharing, Raja. Also. All right, that's all I have today. Have a wonderful rest of the day and rest of the coming up week. Thank you very much. Bye bye.
Okay, everyone, back by 7:40.